Okay. Yesterday's lecture we talked about variations. Are there any troubles with variation? Yes.
Number 15.
Number 15. Well, in a variation, the first thing we have to do is get the formula. That's important, the formula. So number 15, it says Z varies. That means Z is equal to K. Directly. Oh, inversely. Inversely. That means what follows going to come in the denominator as the sum of x squared and y. Sum means to do what? It means to add. So there is the formula. Our job now is to find the value of K. Well, they give you enough information. They say Z is 12 when X is 4 and Y is 6. Now it's an arithmetic problem. We get 12 is equal to K over 16 plus 6, which is 22. Now we have to clear fractions. We multiply both sides by 22. Well, let's see, 220 and 64. 264. There's K. Okay. Any others you'd like to see worked?
22.
22. Here's, I think, a form of Boyle's law.
Yeah.
Dealing with
Volume and pressure.
Is that Boyle's?
Yeah.
You have chemistry?
I think. No, I haven't.
Okay. This is the volume, V, varies, equal K, directly as the temperature, T, and inversely as its pressure, P. So there is the formula. V is equal to KT over P. Now, our job is to find, once we have the formula, determine the value of K. Well, we have enough information to determine the value of K. This is a gas occupies 20 cubic feet. That's its volume. When the temperature is 300 and the pressure is 30. Okay? So now, I don't know how you do this. If I was me, I'd work the fraction out. 300 over 30 is 10. I get 20 is equal to 10K. K would equal 2. So there is the value of K, Tim, 2. Now it says go back to our formula 1 and replace K by its value. So we get V is equal to 2T over P. And that becomes our new formula. Now it says, hey, what will the volume be? What will the volume be when the temperature is 360 and the pressure is 20? Now let's see, zeros, the twos, 36 cubic feet, is that right?
Yeah, cubic feet. Because it's a volume.
There it is. Nice and easy. Because again, I like to repeat, this is the kind of problems you have in physics and chemistry. Nice problems. Okay, let's go on. Okay. Now, on the board I have an equation. X plus Y is equal to 5. What is the geometric representation of this equation? A line. Very good, Tim. This is a line. Notice all our variables are first degree aligned. So X plus Y equal 5 is a line. X minus Y equal 1 is a line. So what we have are two lines. Now, if I draw these two lines on the same set of axes, what could happen? What possibilities exist in regard to these two lines?
That eventually they'll intersect.
They could intersect, right? They could cross. Or
Could be parallel.
they could be parallel, or they could be the same line. They're not, but they could be. So these are the three possibilities. Now, Lynn, you said that these two lines could intersect. I agree, they could. If they intersect, Lynn, how many places can they intersect? One and only one. Our job is to find this point of intersection if it exists. So the first way I'm going to do it is I'm going to graph these lines. I want to draw a picture of each of these lines. Our first line. X plus Y equal 5. Well, I'm going to graph this by the intercept method. When it crosses the x-axis, y is 0, so y is 0, you get x equal 5. When it crosses the y-axis, x is 0, so you get y equal 5. So you have your line. And the name of the line is x plus y equal 5. There is the first line. Now we graph the second line. And again, I'm going to do it by the intercept method. When it crosses the x-axis, y is 0. So I come out with x equal 1. When it crosses the y-axis, x is 0. So y would come out to be a negative 1. And there's the second line, x minus y equal 1. Now, if you do this on graph paper, it will come out exactly. Notice they do intersect. They do intersect, and they intersect at one point. Remember, though, a point is an ordered pair. What ordered pair makes up this point of intersection?
2. Wait, no. 3, 2.
3, 2. Very good. Even as rough as this graph is, it's pretty close. 3, 2. 3, 2 is the point of intersection of these two lines. Now, Karen, this point 3, 2 is on which one of those lines? Both lines. Everybody agree? It's on both lines. So this point 3, 2 better make both of these sentences true. Well, let's check it. 3 plus 2 is 5. 3 minus 2 is 1. It does. And that is the only point that will make both of these sentences true. Okay? So this is the graphical way of finding a point of intersection of two lines. Now this has some drawbacks. In fact, it has quite a few drawbacks. Very serious drawbacks. One, not too serious, it takes time. Depending upon the equations, it takes some time. It takes a lot of time. The equations we have are very, very trivial. If you have more difficult equations, it take a lot longer. Also, the point of intersection. This point came out nice, 3, 2. If the point of intersection was 17/4 and 15/8, no way you can get it from the graph, or it would be very difficult. You have to really scale your grids down to 1/8 in order to make a good, accurate picture. So this is the drawbacks of the graphing method. So there has to be other methods, algebraic methods, and there are. There are 3 methods. 3 methods. And we're going to talk about one of these algebraic methods of finding points of intersection given two lines today. The method we're going to talk about is called the elimination by addition method. The elimination by addition method. Okay, notice what we have. We have two equations, two unknowns. Two equations, two unknowns. We don't know how to play with two equations, two unknowns. The only thing we know how to work with is one equation, one unknown. So our job is to try to get rid of one of these variables, eliminate one of them, so that we come out with one equation, one unknown. To do that, we try to get one of the variables, either the x's or the y's or whatever, to have the same coefficient but opposite signs. Now if we take a look at this one I picked out a real nice easy problem. As you can see, both variables have the same coefficient. 1, 1, 1. Do any of the variables have the same coefficient and opposite sign? Mm-hmm. Yeah, the y's. Now what's the method called? It's called the elimination by addition. Once we get the variables that have the same coefficient, opposite signs, we just add the two equations up. Equals added to equals. If I add these two equations up, Beeb, what do I get? Add these.
X.
Add.
2x equals 6.
Yeah. Notice what we have, Beeb. We have one equation, one unknown. A very, very, very trivial equation. We solve for x.
X equals 3.
X equals 3. We now have the value of x, but we have to find the corresponding value of y. Well, how are we going to do that, Beeb? I have x. I now know that x is 3. I want to find out what y is. Okay.
Replace the x by the 3.
Yeah, go back to one of the original equations. It doesn't make a bit of difference which one. And replace x by its value. I'm going to go back to equation 1. Let me mark these. 1, 2, so you know which one I'm talking about. I'm going to go back to equation 1. Every place I have an x, I put a 3 in. So I have 3 plus y equal 5. Again, notice what we have. We have one equation, one unknown. We have no troubles with any one equation, one unknown. We solve this, we get y equal 2. Remember though, this is a point. A point is an ordered pair. Our ordered pair is 3, 2. Now, what we do is we use the second equation to check it, to make sure this point is correct, that we didn't goof. We go to the second equation and plug in these values. 3 minus 2 is definitely 1. It checks. Notice, it's the same answer as graphing. It has to be. There's only one point of intersection, Lynn told us. If it's 3, 2 on graphing, it has to be 3, 2 no matter which method you use. Okay? Now, we're going to be spending most of the semester, rest of the semester, right here in doing this type of problem. So let's try one. There we go. Two equations, two lines. I'll name them 1 and 2. Your job is to find the point of intersection of those two lines if it exists.
Both coefficients have to be the same to get 0.
Okay, you suffered enough on this problem. If you were getting it, you should have it by now. Karen, I'm at you. Our job is to get one of the variables to have the same coefficient, the opposite sign, so that when we add the two equations, we lose that variable. Karen, does any of the variables have the same coefficient? No. The x's are different, the y's are different. Do any of the coefficients, have opposite signs? Do any of the variables have opposite signs?
Y.
The y's. So I want to attack the y's. I want to try to eliminate the y's. So my job now is to get their coefficients to be the same numerical value. Okay? Well then, this is 4, this is 3. What would be the LCM for these 4 and 3, Karen? What number could I make them both?
12.
12, sure. That's my job. Make them both 12. Well, how can I make this a 12? What do I have to do with it?
Multiply everything by 3.
Multiply the first equation by 3 and multiply
The second by 4.
second by 4. Well, let's see what happens. If I do that, I have 9x plus 12y equal 48. Remember, she said multiply equation 1. It means every single term in equation 1 by 3. She said multiply equation 2 by 4. If I do that, I have 8x minus 12y equal 20. Notice the y's. They now have the same coefficient, opposite signs. Okay, Karen? Now let's add these two equations. Once we get coefficients to be the same, opposite sign, we said elimination by addition. Well, if you add these two, what are you going to get, Karen?
17x equals 68.
17x is equal to 68. Notice, one equation, one unknown. We now solve it. Divide through by 17, we get x equal 4. So there is x. We now have to find the corresponding value of y. So we go back to the original. Always the original, because you might have made a mistake going from the original when you multiplied. It will check in your mistake, but it has to check an original. So we go back to number 1. It says 3 times x. Well, that's x is 4. Plus 4y equals 16. It gives us 12 plus 4y equal 16. 4y would equal 4. Y therefore equals 1. So there is our order pair. Our order pair is 4, 1. Check it in equation 2. Remember, you use equation 2 to check it. You can't use equation 1 because that's where we got it from. So you go to equation 2. It says 2 times x. That's 2 times 4, that's 8. Minus 3 times y. Well, y is 1. Minus 3 times 1 is 3. 8 minus 3 is definitely 5. It checks. Okay? Everybody got the idea. Let's try another one. There you go. 2 equations. The first equation says x minus 3y equal 14. Second equation says 5x plus 2y equal 2. Find the point of intersection of those two lines if it exists. Okay. Lynn, we have two equations.
Not yet.
That's why I called you, Lynn. You weren't finished. What we're trying to do is we're trying to eliminate one of the variables. Which variable did you go after, Lynn?
The X.
The x. You want to get rid of the x's. Is that what you did?
I started to.
Oh.
No.
You could. Doesn't make any. How'd you get rid of one? How'd you get rid of the x's?
Multiply by 5.
Multiply this by 5? And this by?
1.
That won't get rid of the x's. No way.
Oh, it would have to be negative,
Yeah.
Yeah.
Yeah, so it'd be best to go after the y's because they already have opposite signs. Won't make any difference if you did, worked it right. It would come out the same as we're going to show you. Okay, so we want to go after the y's, Lynn.
Using LCM is 6.
Okay, what are you going to do with equation 1?
Multiply by 2.
And the second equation?
Multiply by 3.
Okay, Lynn, let's go. Multiply by 2.
2x minus 6y equals 28.
Multiply the second equation by 3.
15x plus 6y equals 6.
Add the two equations up, Lynn.
17x equals 34. Thanks a lot. Can't.
Okay? What we have here, Lynn, is one equation, one unknown. We're interested in x. 17x equal 34. X would equal?
Does that divide?
We get 2. X is equal to 2. So there we have x. We now have to find the corresponding value of y. We plug it in right in equation 1. X is 2. So we come out with 2 minus 3y equal 14. That gives you a negative 3y equals 12. Y would equal negative 4. Your order pair, therefore, is 2, negative 4. X is 2, y is negative 4. Check it in the second equation. It says 5 times x plus 2 times y better equal 2. Well, 5 times 2 is 10. That's a negative 8, and that does equal 2. Okay? Okay, we have two equations, two unknowns, two lines. I'd like you to find the point of intersection of those two lines. The first line says 7x plus 3y equal 13. The second equation says 4x plus 5y equal 14. Find the point of intersection.